Okay, we talked about best subset selection. There is another selection method called stepwise selection. Let's get to it now. Okay, now, right. So for when we have very large number of variables, we cannot really use the best subset selection. As you already can tell, we got too many models to compare if P is large. So this is an alternative method, this stepwise selection, which would explore a much smaller search space. So instead of brute force looking at each of the 2 to the power of P models, this method looks at a smaller subset. It's in a stepwise fashion. So you start with a model with no predictors, and then you add predictors to the model one at a time until all the predictors are in the model. But at each step, when you add predictors, the one you are going to add is the one that gives the greatest addition to improve to the fit. Okay, so this is basically the basic idea of this stepwise selection. But let's look at the detailed algorithm for the detailed algorithm for one of them, which is called forward stepwise. But we will also have backward stepwise. Let's look at this one first. So again, let's use this M0 denote this null model which contains no predictors. And for this K from, oh well, this one should be K from 1. Oops, let's see. Yeah, K from 0, yeah, because we use P minus K here. So K from 0 to P minus 1. We will consider the P minus K models that add 1 predictors to this, to MK. And we pick the best among this MK, this many MK models, and we will call it MK plus 1. And here the best is defined as the model with smallest RSS, or use the largest R squared. So this one is using the data directly, your training data, the data you have for modeling directly to get the RSS and the R squared. So when you, when you add variables to the model. And from this M0 to MP models, you will select overall the best one with the metrics that we mentioned a little bit from previous section. On the best selection, we talked about this C, P and BIC, AIC, and R square, adjusted R square. And I think I made this wrong. This cross-validation prediction error, we actually have already, oops, why this? Yeah, we have already talked previous week. Yeah, I think I changed this, I modified this size, but it turns out I didn't. Okay. Well, anyway, this is like when you do it in a stepwise fashion, where you have to evaluate the model. Like you add 1 predictors at a time, and you choose which one to add into it. Well, this is just like the idea for this selection method, but we will end up use the use R function to do this for us. I'll talk a little bit about the pros and cons for this forward stepwise. And apparently it's more computationally more computationally trackable than best subset. Well, you only compute one null model plus p minus k models for each value of k. So that would give you 1 plus p times p plus 1 divided by 2 models, far less than 2 to the power of p, right? So for p equal to 20, if you use best subset, it will compute, well, this many models. And if you use forward stepwise, you only do 211 models to compare. So this is way easier or faster by comparing to this many models to compute and compare. But the price that you pay is that you are not guaranteed to find the best model, because we didn't check all of them, right? So suppose the best model of the size 1 would have x1, and the best of size 2 would have x2 and x3. If you use this forward stepwise, you start with 0, and then you add 1, and then you add another. So this forward stepwise will fail to select the best model in this case, because it will look for x1 plus 1 additional variable when you try to find the best for size 2, right? It will definitely have x1 in it already. Okay, so stepwise selection will not guarantee to find the best model. So this is another advantage. It can be used when n less than p up to a model with n predictors. Okay, we said when we have p greater than n, then you basically cannot like compare all of them. Yeah, this is when you use forward stepwise, you can do the model selection, but it will only do up to n predictors. Okay, and another stepwise selection is called backwards stepwise. It's very similar. Backwards stepwise selection will begin with the full model and iteratively removes the least useful predictor. Okay, it will remove decide which one to remove before it removes one. Okay, and also similarly, it only has to compute this many models, and it's not guaranteed to find the best one, the best subset. But with backward stepwise, it cannot be used if n is less than p. So if p is really large, you cannot start with the full model, because it cannot be fit if the sample size is smaller than p. Okay, and detailed algorithm for this backward stepwise is that we use MP to denote. Oh, sorry about the typo. Oops, no, sorry. I take it back. So we will use this MP to denote the full model. It's no longer the null model. So MP is the full model, and it contains all predictors. And now K from P to, it goes down from P to 1, and we will consider the K models that contains all but one predictors from MK. Okay, so contains all variables except one from this MK. And we pick the best among these models and call it MK-1. And here the best is defined as the model with the smallest RSS or largest R squared. Okay. And this is like when you have the same size of models, you can use this. We select the overall best model from this M0 to MP, use this matrix. Oh, wow. Here I changed it, but previous one I didn't, like this cross-validation prediction error, which we discussed last week. But for the previous two, I forgot to change it. Well, anyway, we talked about this last week, and we have mentioned this a little bit from previously, but we will have a more detailed slides, a couple slides about this in the end. Just yeah, this is the backward stepwise. Yeah, we talked about stepwise selection for forward stepwise and backward stepwise. Well, these approaches, they actually give you a similar model in the end, but not necessarily identical, because you see their algorithms are slightly different. There are some other approaches that they are hybrids of forwards and backwards. That is, like, if you think we're adding variables, but also checking at each step. So we evaluate at each step and all variables in the model. So check will decide which one to remove and which one to add. Okay, and if you're interested in this, a common version is called stepwise regression, or you can Google that if you're interested in that. Well, let's take a look at how do we do the backwardness and forward stepwise in R. See, oops, yeah.